Hello everyone, my name is Shwetal More and this is my submission for Data Science, Altair Data Science contest at NMIT. Today I will walk you through my predictive analytic project for optimizing farm productivity using Altair RapidMiner AI Studio. We'll explore crop yield prediction, sustainability score, sustainability insight, and accessible recommendation all derived from real agriculture data. Uh, Let me first introduce my data set. So the dataset contain around 10,000 records of farm data with following columns: farm ID, which is the unique ID for each farm, then soil pH level of the soil, then moisture content in the soil, which is 0 to 50%, then the temperature in degrees Celsius, uh, then the rainfall in millimeters, then the crop type, which has four crops, which is rice, soybean, wheat, and corn, then the fertilizer uses in kilogram, then the pesticides uses in kilograms, then the crop yield, that is yield of the crop in tons, and the sustainability score, that is environmental sustainability score from 0 to 100. Now, if we go back to design mode, so let's first see the selected ML model here. So this is, so first I have done a data training and uh, have, which is like first I have read CV, then selected attributes, then normal, then converted the alphabetical parameters to numerical, then replace the missing value, then set role, which is the target attribute of our uh, model, and then normalize all the columns, then split the data into training and testing set, which is of 30, 70 to 30, that is 0.7 to 0.3 range. Then I have used various models, which is like this is random forest, decision tree, grand Garian boosted tree, and linear regression to find out which model suit our dataset the best. Now let's run this. And so as we can see, I have selected random forest dataset because the performance vector by the random forest is comparatively less as compared to other models. That is, root mean square error is for decision tree is 2.627. GPT is 2.604. Then LR, that is linear regression, is 2.629, and random forest is 2.607. So the as less the root mean square is, that better the model works. So I have chosen the random forest. As we can see, it calculated weight for each attribute based on the parameters. And the random forest decision tree is also created. So the selection is starts and it shows how everything is selected. So total five random forest trees has been selected. Now let's look into the uh, visualization part. So the key finding from my model is that the wheat shows the highest average yield among all crops, closely followed by soybean, which is the yields produced by wheat is 5.467 tons and soybean is 5.474595 ton. Sustainability score finding is also highest for wheat, that is 50.38, reinforcing its position as the best performing crop. Then the model performance, random forest prediction, that is RMSE score, that is root mean score square error, is 0.45 tons. For model predicts yield within 0.45 ton on average, and R square is 0.28, that is 82% of yield variability explained by input features. Top influences features are soil moisture, which has 28% impact on crop yield, then rainfall, which has 22% impact on crop yield, and fertilizer uses, which has 18% impact. So now let's view the graphs. This graph shows the average crop yield and average sustainability score of each crop. So as we can see, for the blue graph shows the crop yield in tons, and the green shows the sustainability score. As we can see, the crop yield for uh, corn has the highest crop yield, which is around 5.43%, and the sustainability score is highest for wheat, that is 50.37 percent. And so next is the bar graph showing maximum predicted crop yield for each crop. The here blue shows the wheat crop, green bar shows the soybean, orange shows the corn, and black shows the rice. As we can see that the crop that is corn has 1.75% of maximum predicted crop yield, and wheat is 1.72 tons as compared to other crops. So bar graph showing average pesticides and fertilizers used for each crop. So the average blue graph shows the average per pesticides uses in kilograms, and green shows the average fertilizer uses in kilograms for each crop. So the pesticides used for corn is 10.37. That is, each and every crop has almost 10 kgs of pesticides used. And similar goes for fertilizer, where 125 kgs of fertilizer is used for getting the proper crop yield. Now the graph showing the sustainability score. So this is the sustainability score. The maximum is 99.994, which is almost perfect score. Then the upper quarter is 74, that is this line, and median is 50, and lower quartile is 25, that is the maximum sustainability score for each crop is 74.93%. Medium is 50.23%, and lower quartile is 25.97%. Similar for crop yield, which is around maximum upper quartile is 7.74 tons, median is 5.49 tons, and lower is 3.37 tons. Now this is the bar graph showing the predictable sustainability score for crop yield, which is taken in average. So it's not directly linear. Higher sustainability score might slightly reduce the yield in short terms due to the reduced chemical uses, but in better long term. So we can see that at minus 1.534 has the highest crop yield, that is tons. And so yeah, similarly this graph shows the crop yield in tons for each crop. So this graph showing the fertilizer uses affecting soil pH level. So soil pH level affects the fertilizers, like how the fertilizer affects the soil pH. So at 54.61 kg is used, and the soil pH is around 6.37. Whereas if 197 is used, then also the soil pH is around 66.178. That means the fertilizer can decrease the soil pH if more fertilizer is used. Then the graph showing average pH level and moisture required for each crop. Then this is blue is soil pH, and the green graph is soil moisture. So each and every crop require around 30% soil moisture, whereas the crop pH should be around 6.5. Then the average rainfall and temperature required for each crop. So average temperature required for each crop is around 25 degrees Celsius, whereas corn require around 24 degrees Celsius to gain the maximum crop yield. And the average rainfall required is 147 that is 175 millimeters, which to gain the highest crop yield. So that's it from my side. Thank you.